The physics behind everything. How does the world around you work? Why do the things you use every day have a scientific side you never imagined? Have you ever stopped to think about how some things that seem so simple in our daily lives hide incredible scientific secrets? Why does everything you throw up always fall back down? How is it possible for such a heavy airplane to fly without falling? And that bouncing ball sound, why doesn't it bounce forever? And more, what happens to the molecules? Inside a microwave that make your food heat up in seconds? How does a light bulb turn on so quickly, almost like magic? And ice, why does it float in water, unlike most things? If you've ever been curious about any of these things, stay with me. Today, we're going to dive into the secrets of everyday physics in a simple and fascinating way that will make you see the world with new eyes. You'll understand how science is present even in the smallest things in your routine, and why, even without realizing it, you are surrounded by it every day. Are you ready to find out? Let's go. Why do things fall? Have you ever noticed that everything you throw up always comes back down? This happens because of an invisible force called gravity. It's like Earth is a giant magnet pulling everything toward it. Gravity acts on everything and everyone. Rocks, apples, people, and even the air. But you know what's even more interesting? This force is always there, even if you don't see or directly feel it. Gravity was discovered by Isaac Newton, who, according to the famous story, was resting under an apple tree when an apple fell. He started wondering, why did the apple fall down and not go up? This thought helped him realize that the Earth exerts a force that attracts everything toward its center. Now, did you know that gravity depends on the mass of an object? Mass is the amount of matter an object has. The greater the mass, the stronger the gravity it exerts. Earth has an enormous mass, so gravity here is quite strong, but not as strong as on larger planets like Jupiter. That's why on the Moon, which is much smaller than Earth, things weigh less. Astronauts can take those huge leaps because lunar gravity is only 1/6 of Earth's. But gravity doesn't just work on our planet. It's what keeps the Moon orbiting around the Earth and the planets revolving around the Sun. Without gravity, there would be no stars, planets, or galaxies, and everything would be chaos. So next time you drop something on the ground, remember to thank gravity for keeping everything in order in the universe. Why doesn't an airplane fall? When we see a huge airplane in the sky, it almost seems like magic that it can fly, right? After all, it's so heavy and made of metal. But the secret to why the airplane doesn't fall lies in the combination of science and engineering, especially in the shape of the wings and a force called lift. Let's break it down. The airplane's wings are specially designed. The top part is more curved and the bottom part is flatter. When the airplane moves forward, the air around it has to flow over these wings. The air moving over the top of the wing travels faster, while the air below moves slower. This speed difference creates an upward push called lift. It's like the airplane is being lifted by invisible hands of air. This lift needs to be strong enough to counteract the airplane's weight and keep it in the air. Now, what moves the airplane forward? The engines. They generate a force called thrust, which is like the engine of a car, only much more powerful. This force pushes the airplane forward, while the wings transform this movement into lift. But that's not all. The pilot also plays a crucial role. They control the airplane using devices like rudders and flaps, small movable parts on the wings and tail to adjust tilt, altitude, and balance. All this works in harmony with another force, drag, which is the resistance of the air trying to slow the airplane down, similar to when you feel the wind pushing your hand back when sticking it out of a moving car. Finally, there's gravity, which is always trying to pull the airplane down. But as long as the lift is greater than the airplane's weight, it stays in the air. So, an airplane doesn't just fly, it does so safely, thanks to this perfect dance between natural forces and human ingenuity. Why does a ball bounce? Have you noticed that when you throw a ball on the ground, it doesn't just stay there, but starts bouncing several times until it stops? This happens because of an exchange of forces between the ball and the ground. Let's break it down simply. When the ball hits the ground, it deforms a little. It's like a spring that gets compressed and then tries to return to its original shape. This deformation stores energy, called elastic energy. When the ball returns to its normal shape, this energy is released, pushing the ball back up. It's like the ball is saying to the ground, "High five," and the ground returns the force with the same strength. But why doesn't the ball bounce forever? That's because not all the energy returns as movement. Some of it turns into heat. It's so little that you don't feel it. And some turns into sound, like the thud-thud noise you hear each time it bounces. Additionally, the air around creates resistance, called friction, which also helps to reduce the ball's energy. Now, what if the ball was in a place with no air and no friction, like in space? There, nothing would slow it down, and it would keep bouncing forever. But here on Earth, each bounce is slightly smaller than the previous one until all the energy dissipates and the ball stops. And there's more. The type of ball and its material also make a difference. Why can we walk without slipping? When you walk, it seems super simple, right? But in reality, a lot of physics is happening to make it possible. The secret lies in two important forces: action and reaction, and friction. Let's understand this better. To take a step, your foot needs to push the ground backward. And guess what happens? The ground pushes back forward. This exchange of forces is what we call action and reaction, which is one of Isaac Newton's laws. It's like the ground is helping you move. But that's not enough. If there were no friction, which is the grip force between your foot and the ground, you would end up sliding because there wouldn't be enough support to keep your balance. Friction works like an invisible brake that prevents you from slipping. That's why you can walk firmly on rough surfaces like concrete or sand where friction is high. But on ice or wet floors, where friction is very low, it's easy to slip because there isn't enough force to hold your foot in place. In these conditions, it's like trying to walk on an ultra-smooth surface that offers no resistance. Now think about shoes. They also play an important role. Sneakers with rubber soles, for example, increase friction, helping you walk better. On the other hand, shoes with smooth soles can make you slip easily, especially on wet floors. And there's more. Even when you run or jump, friction is at work. It gives you the push needed to go faster or land without falling. So next time you walk or run, remember that it's the combination of action, reaction, and friction that keeps your steps firm and prevents you from sliding along the way. How does a microwave heat food? The microwave seems like magic, right? But it's actually pure science working in a very interesting way. It uses electromagnetic waves, called microwaves, which are invisible to our eyes but super efficient at heating food. These waves are like messages telling the water molecules inside the food, "Let's dance," and the molecules obey. They start vibrating rapidly, moving back and forth. This movement generates heat, and that's how your food gets warm. The most amazing thing is that the microwave heats food from the inside out. That's because the waves penetrate directly into the food, reaching water molecules in multiple layers at the same time. This is different from a stove, which heats food from the outside in, as the heat comes from the surface. But there's something important. Not all materials heat up in the microwave. Plastic, glass, and ceramic don't have water molecules, so they just serve as containers and never put metals inside. Metal reflects microwaves, which can cause sparks and even damage the appliance. Now you know, the microwave is like a dance floor for water molecules. It's not magic, but science using waves to heat your food quickly and efficiently. Why does light turn on so fast? Have you noticed how when you flip the switch, the light turns on almost instantly? This happens thanks to electricity, which is like a current of super small particles called electrons. These electrons travel through wires at high speed, like a team of runners delivering energy straight to the light bulb. Once they arrive, they make the atoms inside the bulb excited and start vibrating. This vibration is what generates light. In incandescent bulbs, the electrons heat up a very thin wire called a filament until it gets so hot that it starts glowing. In fluorescent bulbs, electricity makes a special gas inside emit light. And in LED bulbs, the process is even more efficient. Energy is directly converted into light without needing to heat anything. That's why LED bulbs are faster, last longer, and save energy. The most incredible thing. All of this happens so fast that it feels like magic, but it's actually pure science working in the blink of an eye. Why does ice float on water? Ice has a special characteristic that sets it apart from most things. It floats on water instead of sinking. This happens because when water freezes, its molecules reorganize in a unique way. Instead of staying close together, like in liquid water, they form a kind of network with spaces in between, like several hexagons stuck together. These spaces make ice less dense than water. Density is how much matter is packed into a certain volume. In the case of ice, it takes up more space but with the same amount of water. This makes it lighter than liquid water, allowing water to push it up, making it float. It's the same principle that allows steel ships, which are much heavier than water, to float. They are designed with hollow parts that increase volume and decrease density. Now, if you put something denser than water, like a rock, it sinks because the water can't generate enough force to push it up. It's fascinating to think that this property of ice is essential for life on Earth. In frozen lakes, the ice stays on the surface and insulates the liquid water below, protecting fish and other organisms during the winter. Amazing, right? Science is all around you, and understanding how the world works can be simpler and more fascinating than you think. If you want to learn more about the secrets behind everyday things, subscribe to the channel and leave your like. This way, you help us bring more amazing content to you. Don't miss this journey of knowledge.